Hi guys, this is the second video in which we are going to take a look and start the course on containerization. If you have not done the setup yet, please watch my first YouTube video in which I tell you the things that are required for the setup to be complete. In this video, we are going to take a look at some of the things that I've kept in a GitHub repository that I have asked you to clone in the first session. Again, if you have not done that, please see that video and do all those setup requirements. So before I begin, I'm just going to tell you how to clone that repository. So I'm just going to clone that. This is the URL. Just press an enter. After that, you should be able to clone the repository now, and the folder should be learn minus containerization. Let's jump into that folder, and when we list the contents of that folder, you should see a readme file at the top of it. This file is basically a simple description about what we are doing here, what this repository actually means, and then you would see some of the folders with the day numbers appended to them. It's basically, I have kept it smaller so that every day we are going to discuss some agenda, some exercises to do, some learning, some questions. All of them, you can find them in these folders. So as and when we proceed in this course, we will keep on increasing the day numbers, and we are going to use those folders for that day only. So I believe you all have cloned it till now. The repository must be available with you. Feel free to browse through the contents of it. And now let's jump into the first day and see what the contents are. So it just has one readme file. I'm just going to output it. So the agenda for this day is to understand the problems that we have when we share our applications and deploy them. What problems do we face when we do the above? Discuss the alternative solutions to the above problems, and where is Docker helpful? So let's talk about these 4 questions in detail. So ask yourself, how do you share your source code or your application with your friends? I usually used to give out my source code along with a readme file, or a make file or a build file, so that they can just follow the instructions or run a starter script, for example. That can be a batch script, that can be a shell script, or whatever you like, maybe a Python script as well. So they'll have to run those scripts and install the softwares written in that, and do the configurations as well to your environment. Now the problems I used to face in that was some of the environments were not consistent enough. For example, you're deploying a Java app, and the environment you're deploying in has some conflicting environment variables in it. So because of those environment variables, you might have some problem. I'm going to show this via an example later on, but for now, just understand that when we share something and the environment is unknown to us, problems usually occur. The other way was to deploy our apps somewhere online, like on Amazon Web Services, on Heroku, on GitLab, on GitHub, wherever you want. But those all things, and those things are like really cumbersome. They take a lot of time. They'll take a lot of learning from your side as well. But it's fine even then, because of that learning curve. If it's fine if you just can deploy them, but sometimes the app itself needs to be built from scratch, from the source code itself. That is what most developers are after, when they want to customize the open source software. So that itself is a problem. You again need to send out some build script, something other than that, for your configuration of the environment. For your software has to be delivered alongside your software. So that is also a problem. The other way around, or I would say that what people used to do earlier was they used to share the platform along with that. For example, my app only runs in a Linux environment. then maybe I can just share a VirtualBox image. That itself is quite heavy because the OS itself is going along with my code. Plus, the other restriction is that the services like GitHub and emails like Gmail, Yahoo Mail, they don't provide you much space, to send large attachments like these. So you either end up uploading those heavy files into your G drive, you give them a link and they'll download it. Again, a time-consuming process. So the problems again, while you share all those stuff, you have some manual configurations for your shared applications. You have some inconsistent dev environments. Like I've told you, your environment in which you have tested your app and the environment you're expecting it to run might be different because of environment variables, some configuration changes done by the user. So there are a lot of probabilities that your environment can go wrong, and hence your application may not work properly. Other thing is that there is too much setup complexity. When you deploy apps that have some deployment configuration attached to it, or if you have a lot of configuration done to your environment before your app can run, that also takes some time, and writing all that in a shell script, it's also time consuming. Then you write in order to resolve all those things, you end up writing code for setups, for configurations, for environment validations, etc. And it's all very painful, and we all should understand that. Sharing our environment itself is large in size. Like I said before, that when you share your VirtualBox images, they're quite heavy as well. So these are all the problems, and maybe much more. You also guys can comment in the comment section that what all problems did you face when you were not introduced to containerization or such technologies, and how are you, or how did you share your applications with your friends? I'm talking about source code sharing basically. GitHub is just a way to download and to store and to manage it, but what happens when you clone that stuff and you try to build it on your own? What problems did you face? And let's try and understand now the importance of Docker, how it is going to help you. So first of all, you declare your environment as a file. Just like you used to share a README file or a script file earlier, which was not platform independent. Now we have a file, this sort of platform independent, because we write something in it, just one statement in it, that is going to pick and create a platform for you within your host machine. So that is what declaring your environment as a file. I'll tell you in detail later on. And installation is just one command that preps everything for you. So you run the Docker, and using the file that we've created above, it's called Docker file, by the way. So when you run that, when you install that file, it creates the environment, does all the modifications that you will require, and install that on your host machine. And how is that easy? Because not only you're just sharing one file with each other, just the Docker file, and anyone with the Docker software can just install that and deploy your whole application without further ado. And the other thing that I like about it is that Docker has really evolved in the last few years. So a lot of services like Heroku, GitHub, Travis, etc., they have given us a lot of facilities that help us use Docker on their platform. GitHub and Travis also have a lot of integration with Docker. Maybe we can explore that later on. But for now, just understand that with Docker, we have a lot of ease of sharing and deploying it on cloud platforms. I've just added one link. You can visit this link just to understand more benefits of Docker and why is it helpful. About one of the most important point, and something that is really talked about Docker, that Docker is lightweight. And one more thing, that it brings along with it environment similarity and in complete isolation from your host machine. That is a lot of technical stuff. Let me just draw something for you. So this black box, consider this as your laptop running an operating system say Linux, for example. And on top of that, you install some Docker containers. I'm going to explain it later on what a container means, but for now just understand that you have some Docker containers running on your operating system, and this walls that you see here, the black partitions basically, they all signify that these containers will not conflict with each other because they are all in their own self and not interacting with each other, unless obviously you want them to. But they're all sandboxed. That is the term that we usually hear. By sandbox I mean they will just be available in their own boxes. Like this platform here will not be able to interact with this container here, and this will not be able to interact with this container here. So all the environment variables in your environment here will not conflict with the ones here, with the ones present here. So you have this environment isolation, which was a pain point earlier. Let's see that some of you may say that I can easily share an VirtualBox image with my friends, and then they can just install it as it is, and that will also guarantee this isolation. I would say absolutely correct, that will be giving you the same level of partitioning and sandboxing your environment. So the variables, like in this green figure, if you see here, this image, we have multiple OSs. For example, this can be your Mac OS VirtualBox image, and this can be your Windows, for example. As you see, I have also created a partition here, a wall here, so that anything that happens here, any variables, any ports, or anything that you're running in this side will not be conflicting with this side. So this is also giving you an isolation. So what is the difference? So if you clearly see the images here, I have just one OS layer here, and all these containers are actually sharing that OS rather than having one copy of OS along with them. And if you see here in your earlier approach, in your VirtualBox environment, I'll just write VBox here, and so this is your Docker and this is your VirtualBox environment. So the main difference, as I was talking about, the main difference between both of them is that in Docker, an OS layer is shared between these containers. These all will be sharing this OS, and in this case the OS is one copy that exists in each container. So that is why this will be like 1.2 gigs, and this will be some this will be in some gigs as well, considering the operating system that you have packed into it. For example, Windows here and Mac here. So this is why Docker is called lightweight. This layer will always be a Linux layer. So yes, you cannot natively, the word natively here I'm saying, because you cannot install Docker directly on a Windows system. You need some layer that provides those Linux kernel based drivers and file drivers and all of that. That is why when you download, when we saw that setup video that I've given you guys, in that you downloaded a software, Docker for Windows, for example. So Docker for Windows itself runs a container inside a VirtualBox. So it runs something like this. It has this as a Linux, and on top of it there is an app which is giving you access to the Docker thing. So that is how it is enabling you to run Docker on Windows. And on Linux we just have a lightweight thing called Docker daemon. This Docker daemon it's a software layer again. It runs somewhere here on top of your OS and allows your containers to talk and interact with the driver layer of the Linux operating system and give those file drivers and kernel based routines or some driver access to these containers. So Docker daemon is available somewhere here in the middle between your containers and OS. So that helps helps your containers to interact with your OS. So this is why Docker is lightweight, and this is how it gives you an environment isolation. So that's it for this session. Maybe in the next session we'll look at how a Docker file is created and how it is created and what does it do after it gets created. So till then, take care of yourself, stay home, stay safe, and leave your valuable comments in the comment section below for help me improving this video content. Thank you and have a good day ahead.